18th one. Energy of electron in first orbit of hydrogen atom is X. The energy of electron in third orbit of He plus is. So energy expression, okay, it is in terms of electron volt 13.6 divided by n square into z square. For hydrogen, electron is present in first energy level, right? So for hydrogen, n is equal to 1 and atomic number z is equal to 1. So it becomes minus 13.6 n square 1 square into z square. This is what they have given it as minus x. Energy of electron in first orbit of hydrogen atom is minus x. So for general expression, for any other element like He plus, Li2 plus like that, energy of electron is equal to minus 13.6 divided by n square into z square. But they are asking the energy of electron in third orbit of He plus. So now for helium plus, z is equal to 2 and third orbit means n is equal to 3. So it is minus 13.6 divided by 3 square into 2 square. What is minus 13.6? It is nothing but minus x. Correct now? So therefore, this equation becomes, in the place of 13.6, you can write x, and 2 square is 4 divided by 3 square is 9. Am I right? So in that way, answer becomes 4 by 9 times x. So option 3 is correct.
Sir, can you please explain again, sir?
Yeah. See, energy of electron in first orbit of hydrogen atom is actually magnitude you have to take, otherwise answer becomes plus there. You take it as x. Okay. So hydrogen atom, there is first orbit and electron is revolving here. The energy of electron in third orbit of He plus, they are asking in terms of this x, that's all. Otherwise directly the formula to calculate energy of electron in nth orbit of any species is En is equal to minus 13.6 into z square divided by n square is the formula, correct? But what is this 13.6? It is nothing but x. It becomes x. Energy of electron in first orbit of hydrogen atom is x. So if you substitute for hydrogen, energy of electron becomes, for hydrogen z is 1, correct? No, electron is present in first energy level, n is 1. So it
Yes,
becomes
sir.
minus 13.6 into 1 square divided by 1 square. So minus 13.6. So that minus 13.6 nothing but minus x. So you can take that as x itself. Minus minus cancels. Is it okay? So now we need to express energy of electron in third orbit of He plus in terms of that x. What is x actually? 13.6. Is that okay? Therefore, x is equal to 13.6. Are you understanding? And now what is
Yes,
the
sir.
general expression for any other element? En is equal to minus 13.6 into z square divided by n square, energy. What is 13.6? We found it as x. For helium, what is z? 2 square. They have given third orbit means 3 square. So it's nothing but minus x into 4 divided by 9.
Yes, sir. Understood.
That's all. That means in terms of x, we need to express the energy of electron in third orbit of He plus. X is nothing but 13.6, which we have got it from this first expression. So answer is option 3. Is that complete now?
Yes, sir.
Yes, sir.
If it is done, I am going to remove this part to take next question. So we'll take this. The splitting of spectral lines in presence of magnetic field is.
Second one, sir.
So
Zeeman effect.
magnetic, when a spectral line is passed through external magnetic field, the spectral lines are now subjected for splitting like this. This is splitting of the spectral line in external magnetic field. It's called Zeeman effect. Same splitting of spectral line in presence of external electric field is called Stark effect. This becomes one of the drawback of Bohr's theory. Bohr's theory couldn't explain Zeeman effect and Stark effect. So option 2 is the correct answer. Complete. Next, 20th we'll take. On the basis of Bohr's model, the radius of third orbit is.
Third option, sir.
Yeah. You have to use the expression for the radius. Radius of electron in nth orbit of hydrogen and hydrogen-like species is given by n square divided by z into 0.529, or people write 0.53, no problem. Okay. So now they are asking the radius of third orbit. N is equal to 3. So it's nothing but 3 square. So it becomes 9 times to that of first orbit. N you substitute, so it becomes 3 square 9. 9 times the radius of first orbit.
Sir, can you please explain again, sir?
The radius of electron in nth orbit of hydrogen and hydrogen-like species is this equation. Is that okay? This is general expression. Now, radius of third orbit they are asking that. Okay. It is for hydrogen. If they have not given anything, it is for hydrogen. Okay. For hydrogen, Z is equal to 1. And third orbit means what is the n value? N is equal to 3. Third orbit means n is equal to 3. So what is in the equation? Is it n or n square? It is n square. Is that okay? So radius of first orbit. Let me calculate radius of first orbit. R1 is equal to, for first orbit, what is n value? 1 square. Atomic number for hydrogen 1 into 0.529. That's equal to 0.529. So what is the radius of first orbit? 0.529. Got it? Now radius of third orbit, R3 is equal to, what is n value for third orbit? 3 square. Atomic number 1 into what is 0.529?
R1.
R1, radius of first orbit. So radius of third orbit is 9 times the radius of first orbit. That's the answer. Is that okay?
Yes, sir.
Yes, sir.
Now, if you have written, I'll take out that annotation, whatever I have written. You copy it down.
Yes, sir.
Okay. 21st will take it. If electron, hydrogen, helium, and neon nuclei are all moving with the velocity of light, that means they all have same velocity is the concept you need to take out. Then the wavelengths associated with these particles are, now it is the concept of de Broglie matter wave. Okay, de Broglie matter wave concept says wavelength of the matter wave is inversely proportional to the mass. As mass of the particle increases, wavelength of matter wave decreases. So can you answer this question? Keeping velocity of all these particles same, what is the relation between wavelength and mass now? Wavelength is inversely proportional to mass of the particle. As mass of the particle increases, wavelength decreases. So can you tell me now? What is the
Option
answer?
1.
First option.
Option 1.
Option 1. Because electron has lowest mass, so it will have highest wavelength than hydrogen. Helium has more mass, atomic number 2, neon atomic number 10. So lambda wavelength is inversely proportional to mass of the particle. We know mass of electron is less than hydrogen, that of helium, and is less than neon. Therefore,
Sir, then it is directly proportional to frequency, sir.
no, mass and frequency are not related. What you are saying, the wavelength of matter wave, since it is 1 by m, you should say mass is directly proportional to frequency like
Yes, sir.
that. Correct, no? Uh, you can say as mass increases, frequency increases, means frequency indicates the energy. Energy of the particle obviously increases when mass increases. This is nothing but energy. Okay. So option 1 is correct. When mass of electron is less, its wavelength will be more. Neon. Okay. Shall I proceed now?
Yes, sir.
20 seconds. A golf ball has a mass of 40 gram and a speed of 45 meter per second. If the speed can be measured within accuracy of 2%, calculate the uncertainty in the position. Uncertainty, this is related to Heisenberg uncertainty principle. It is impossible to measure both position and momentum of a subatomic particle simultaneously and accurately. The equation is delta x into delta p is equal or greater than h by 4 pi they have given. Now, can anybody work out and let me know the answer? Speed can be measured within an accuracy. Delta v is 2%. You can take 1 minute time and let me know the answer. Come on. Anybody has got the answer?
Sir, option 3.
1.59, 10 raised to minus 33. Anybody else?
Suggesting option 1, sir.
Okay. 1.46 in 10 raised to minus. Fine. Let me give the solution for this. So delta x into delta p is equal to h by 4 pi. So we need uncertainty in the position. Delta x is uncertainty in the position. Delta p is uncertainty in the momentum. But delta p, uncertainty in the momentum, can be always momentum is mass into velocity, right? So since it is uncertainty, delta p is equal to mass into uncertainty in velocity, you can write. So delta x is equal to h divided by 4 pi into, in the place of delta p, what I have written? M into delta. Let us substitute the values. Oh, let's substitute the values. So 6.625 10 raised to minus 34 divided by 4 into 3.14, that is pi value, into 40 grams must be converted to kg because it has to be in SI unit. Am I right? Now delta V is 2% of the velocity. How much is velocity? 45 meter per second, and uncertainty is 2% of that. So 2 divided by 100 into 45. So somebody told me option 1. If you can simplify further, it becomes 1.46 into 10 raised to minus 33. Things that you need to remember is delta P must be written as M into delta V, and also convert grams into kg. Okay.
Yes, sir.
Okay. Shall I proceed now? I'll take up next question. What will be the wavelength of a ball of mass 0.1 kg moving with a velocity of 1000 centimeter per second? What will be the wavelength of a ball? Mass is given 0.1 kg, velocity is given. So what is the problem it is related to?
De Broglie
De
equation.
Broglie's
Option
quarter
2.
wave concept. Come on.
Option 2, sir.
Okay. So the de Broglie equation, lambda is equal to h divided by m into v. 6.625 or 6.62 in 10 raised to minus 34, no problem. Divided by mass is 0.1 kg, and this 1000 centimeter should be converted to meter into SI unit. So if anybody wants clarity on this, 1000 centi is nothing but 10 raised to minus 2 meter. So this 10 raised to minus 2 and these two zeros will cancel off, becomes 10 meter. So therefore 1000 centimeter is 10 meter. Denominator 0.1 into 10 becomes 1. So answer will be 6.62 into 10 raised to minus 30. Option 2. Is that complete now?
Yes, sir.
24. The basis of quantum mechanical model of an atom is?
Dual nature of electron.
Yeah. So till quantum mechanical model, the wave nature of material particles were not considered. After de Broglie's matter wave and Heisenberg uncertainty principle, actually quantum mechanics was developed. Okay. So then Schrodinger wave equation comes and everything, where the atom structure was given considering the dual nature of all the particles. Okay. So here most appropriate answer is option 3 itself. Dual nature of electron. That is dual nature of material particles. So quantum mechanics is a branch which deals with the properties of matter considering dual nature of matter. Okay. So option 3 is right. We'll take up 25th. We can talk only in terms of probability of finding an electron around the nucleus because
Option 2, sir.
both exact position and exact velocity can't be determined simultaneously. So that is as per Heisenberg uncertainty principle. No. 26th. Which statement is wrong about Bohr's theory? As per Bohr's theory, which statement is incorrect?
Option 1.
Option 2, sir.
Option 2, sir.
Which option?
2.
Okay. Which is wrong statement? Orbit is a three-dimensional area where probability of finding electron is maximum. Option 2 says orbit is two-dimensional track on which electron moves. Orbit, see, second option is what Mr. Bohr told. According to Bohr, which statement is wrong about Bohr's theory? According to Bohr, this is what he told. But what was actually not told is, or not correct according to Bohr's theory is, orbit is never imagined to be a three-dimensional area. Correct? No? Orbit never has been a three-dimensional area as per Bohr's theory. So it is option 1 itself which is wrong. Okay, he said electrons are revolving around the nucleus. So in particular energy levels which are nothing but orbits. So that is a two-dimensional path. What is wrong they are asking? So orbit can never be three-dimensional area, which is then three-dimensional space where electron probability is maximum. Orbital it is. So never about orbital Bohr's theory said. So option 1 is wrong. Okay, but there is little confusion. Be careful. Shall I proceed now? Okay, hope it is done. Shall I take up next question now?
Yes, sir.
27. Identify the correct statement regarding photoelectric effect. Kinetic energy of electron, emitted electron is independent of frequency. Number of photoelectrons emitted is directly proportional to intensity. The kinetic energy of an emitted electron is greater than 0 if incident energy is less than threshold energy of the metal.
Option 3, sir.
Option 4.
Option 4, sir.
Okay. So all are correct, huh?
Yes, sir.
Yes, sir. Option 4.
Okay.
Sir, opt 2.
Option
2.
okay. Is it Nikita?
Yes, sir.
Okay. So see, kinetic energy of emitted electron is independent. See, what is actually photoelectric effect? When a metal is exposed to certain radiation, the radiation of suitable frequency when falls on it, electron gets emitted. This is photoelectron. And the metal can eject electron for a particular frequency that is called threshold frequency, and that corresponding energy is called threshold energy. So it cannot be independent. Kinetic energy, actually you have to incident a radiation minimum threshold frequency. If the radiation has more energy, more frequency than the incident radiation, then the electron which is emitted moves with a certain amount of kinetic energy. So kinetic energy depends on the frequency of the radiation incident. As frequency of the radiation incident increases, kinetic energy increases. But the thing is, this frequency of the radiation should be greater than threshold frequency, not before that. Okay, and so therefore it is not independent, so it is dependent. So one is not correct. Go to third there. Third says the kinetic energy of an emitted electron is greater than zero if incident energy is less than threshold energy. First of all, electron only will not be removed or emitted. So therefore third is not correct. When energy of the incident radiation is less than threshold energy, electron is not emitted at all. So second option says number of photo electrons emitted is directly proportional to intensity. Of course, the intensity of the radiation, when it increases, number of photo electrons emitted also increases, provided the radiation has threshold frequency of energy. Beyond that, so if radiation has high intensity but not threshold frequency, then electrons will not be emitted. So of the three, option 2 itself is most appropriate. Correct.
So can you please explain again, sir?
Now the concept of photoelectric effect is what you need to have in your mind first. So when concept is not clear, then the options also will somehow confuse. Now I'll give you some numerical values. So let's say if electron has to be ejected from some metal surface, the incident frequency should be somewhere like 20 hertz. Simply I'm giving 20 hertz. So if incident frequency is 18 hertz, will there be electron emitted? Yes or no?
Yes, sir.
No. If it is 18 hertz, the electron will not be emitted, because what is required is minimum 20 hertz of frequency.
Okay,
Okay.
sir.
If frequency is 22 hertz, will electron be emitted?
Yes, sir.
Electron emitted. Now, how much is extra frequency from threshold frequency? This 20 hertz is called threshold frequency. Now, if 20 hertz radiation incident on the metal surface, electron emits. If 22 hertz radiation incident on the metal surface, what would happen? Then 2 hertz is extra, right? There's 2 hertz extra. The 2 hertz extra energy will be transformed to the electron, and where electron moves with certain amount of kinetic energy. Is that okay? 20 hertz is required to remove electron. The 2 hertz extra, which is there beyond threshold frequency, will be imparted to electron to move it with certain amount of kinetic energy. Okay.
Yes, sir.
Now let's say we'll take one more case. Let's say there is some radiation which is falling onto the metal surface with 30 hertz. How much is required to remove electron? 20 hertz is threshold frequency. That much is required to remove electron. That is what is threshold frequency. Remaining, how much extra is there? 10 hertz. Correct? No. The 10
Yes, sir.
hertz extra energy will be imparted to the electron to move the electron with certain amount of kinetic energy. Now you tell me, when a radiation of 22 hertz falls onto the metal surface and 30 hertz falls onto the metal surface, in which case electron removed moves faster, 22 or 30?
30, sir.
30. And now this is the concept. As the frequency of the incident radiation increases beyond threshold frequency, then kinetic energy of the electron increases. So kinetic energy of electron is directly proportional to the frequency of the incident radiation. Of course, it should be greater than the threshold frequency u naught. And the number of electron emitted, always number of electrons emitted in photoelectric effect is directly proportional to intensity of the radiation, because a radiation of high intensity possesses more number of photons. A high intense beam means it has more photons. So if high intensity beam is used then more photons will be incident onto the metal surface. So more number of electrons will be removed. Now we'll take up the options. Kinetic energy of emitted electron is independent of the frequency. Is it correct or wrong?
Wrong, sir.
Go to number 2. Number of photoelectron emitted is directly proportional to the intensity of the incident radiation. Right or wrong?
Correct, sir.
Correct. The kinetic energy of an emitted electron is greater than 0 if incident energy is less than threshold energy. Is it possible at all? If incident energy has less energy than threshold energy, electron is not removed at all. Forget about kinetic energy there for electron.
Not possible.
So which is correct therefore?
Option 2.
That's all. If it is done, I'll take up next question.
Yes, sir.
28. Which of the following order is correct with respect to wavelengths of X-ray, radio waves, visible light, IR rays? I have given you one word to remember entire electromagnetic spectrum. Which is that word?
R mu x gamma c.
R mu gamma
Option 2, sir.
Sir,
R
option
mu gamma c, right? No, this is R mu gamma c. So in this way, when you move from R to C, wavelength decreases and frequency increases. So they are asking which of the following order is correct with respect to wavelengths. So if you see X-ray, radio waves has highest wavelength, and then comes after radio waves as per the given option IR. That means B has highest wavelength, then B greater than D, correct now, and then comes visible C, then comes X-rays. So of course it is they have given in the increasing order. So A is least, X-rays, then comes C, B, C, D, B, A, C, D, B. Option 2 is correct. Shall I proceed now?
Yes, sir.
29. Which one of the following is an isobar of carbon 14?
Option 3.
Isobars will have same
Mass.
Yes.
mass number, different atomic number. So option 30. Which of the following statements concerning sunlight is false? It is a form of energy. It cannot be deflected by a magnet. It cannot be, it
Option B.
consists of photons of same energy.
Option
It is a
3.
part of electromagnetic spectrum.
Option B.
Second, it cannot be deflected by magnetic field is correct actually. Sunlight can't be deflected.
Option 3.
3
3,
is
sir.
correct. 3 is a false statement, meaning sunlight contains photons of different energies, because we just have seen electromagnetic spectrum, R mu gamma c. So from all the radiations, there are different photons and different energies possible. So option 3 is false. It consists of photons of same energy is wrong. It consists actually photons of different energies.
Excuse me, sir.
Ah,
So isn't option 2 also wrong? Because sunlight is also an electromagnetic radiation. So
I think what you said is right. It is electromagnetic radiation, but electromagnetic radiations doesn't have mass there, and it has electric field and magnetic field component perpendicular, and any electromagnetic just radiations can't be deflected, whereas particles can be deflected. Having charged particles can be deflected, not the electromagnetic radiations. You should know this. Okay.
Okay, sir.
Electromagnetic radiation doesn't have mass. As a result, they can't be deflected. Okay. So that's the thing. You can write there. Because of no mass, radiations can't be deflected. If electron, like cathode ray waves or anode ray waves, we say, or any other particles with charge having some mass, can be deflected. Next. So now we'll take up questions on quantum numbers and rules governing electronic configuration. Only these 30 questions I have done, right, so far in atomic structure. Did I do another 30 questions in the previous class? No.
No, sir.
Have I done or no?
No, sir.
Okay.
No, sir.
Then I'll take up. Have I posted one more worksheet in your WhatsApp group?
No, sir. Only one.
Now I'll post one more worksheet. We'll work out questions on the second part of the atomic structure. Okay, just a minute. Meanwhile, I'll post the question paper worksheet 2. Meanwhile, you try to answer this question. Let's question book. See if you have got it. Worksheet 2. Adar mele worksheet 1 antiде, don't worry. Since it has been posted second time, it is worksheet. You have got it? Worksheet?
Yes, sir.
Yes, sir.
Right. We'll take up question number 1. For sodium atom, the number of electrons with m is equal to 0 will be. Anybody has got the answer for this? M is equal to 0. Do you people remember the quantum numbers or already forgotten?
Sir, option 4.
Option 4, 8. Now, you need to write the electronic configuration of sodium atom and find out which are electrons present in the orbital m is equal to 0. Okay, so that's what we need to do now. Now, when it comes to electronic configuration of sodium, atomic number 11. See, at least atomic number up to 30. You need to know elements and their electronic configuration in sequence. Okay, so 1s2, 2s2, 2p6, 3s1 is the electronic configuration. You need to find out the electrons present in all the orbitals with m is equal to 0 there. Okay, so m is equal to 0 would be possible in which all orbitals? Let's see now. See, m value, I'll briefly explain how values of different quantum numbers vary with each other. Okay, n indicates shell, correct? L indicates subshell. Subshell S, P, D, F, like that. Even G, H also possible, but these are significant ones. Only electrons are found up to F orbitals or F subshells. M indicate orbital, we know, orbital of electron. And spin quantum number indicates spin of electron, plus of clockwise, minus of anti-clockwise, arrow mark upward, downward, this one. Okay. Now, how exactly each other quantum numbers vary with one the value of one another? Let's see now. Now, m value depends on L value. L value depends on n value. Correct now? Now, for every n value, how many n values, L values can be possible? 0 to n minus 1 we say. Okay, for example, when n is equal to 4, what are the possible values of L? Starts with 0, goes up to n minus 1. 0, 1, 2, 3. 4 minus 1 is 3. It stops there. Now you should know different values of L indicate different subshell. When L is equal to 0, you should know it indicates a subshell, P subshell. 2 means D subshell. 3 means F subshell. Like that, 4 means G subshell. Okay. Okay. That's how exactly L varies with N. Now, how M varies with this L? How M varies with L? For every L value, M can have 2L plus 1 number of values. These many number of values. Okay. And those values will be ranging between minus L to 0 to plus L. For example, say when L is equal to 1. When L is equal to 1. What does it indicate? L is equal to 1 means P subshell. In P subshell, let us see how many orbitals are present. Orbital means m value. Tell me, when L is equal to 1, how many m values are possible? That is 2 into L plus 1. 2 into 1 plus 1 is equal to 3 values are possible. Okay. So when L is equal to 1, it is P subshell. In P subshell, there are 3 orbitals. And those values, each orbital will have its own orientation, right? So the orientation is given by minus L, 0, plus L. So the 3 values possible for M when L is equal to 1 is minus 1, 0, plus 1. So this is how exactly M, L and N values vary. This is completely done in detail in the beginning of atomic structure chapter, right? Let us come back to this now. Na is equal to atomic number 11, electronic configuration we have seen. We need to find out number of electrons in M is equal to 0. Now, which are all the orbitals which possess value M is equal to 0 for S subshell, 1s. What is L value for S? 0. Am I right? When L is equal to 0, how many values are possible for M?
1.
2L plus 1 is the thing. Which are those values? Minus L, 0, plus L is what we use the value, right? When L is equal to 0, how many values are of M is possible? 2 into 0 plus 1, 1. Which is that? When L
0.
is equal to 0, one value is possible. But which is that value? You have to look at this minus L, 0, plus L. So when L is equal to 0, minus 0 plus 0, 0 means 0, that's all. So what is the conclusion? For 1s orbital, M can be 0. Are you understanding? For 1s orbital, M can be 0. Similarly, for 2s, 3s, or any s orbital, m can be 0. So that means you need to count electrons present in s orbitals for this question. And also when it is 2p subshell, for p subshell what is L value? 1. For 2p subshell L value is 1. How many m values are possible for L? I just now told 2 into 1 plus 1, 3 values are possible. 2p L is equal to 1, 3 values are possible. Am I right? So 3 values, which are those? -1, 0, +1. That means there are 3 orbitals with values -1, 0, +1, and there is an orbital with 0 again. There is an orbital with 0 again. Are you understanding? So that means in completely sodium, you need to count the electrons present in s orbitals, because s orbitals have m is equal to 0, and p orbital has, p subshell has 3 orbitals like this, right? There are 6 electrons there. Which are the values possible for m? -1, 0, +1. So you have to count 2 electrons here also, because there is an orbital with m is equal to 0. So tell me now, 2 plus 2 plus 2, and here is again 1. So totally 9 electrons have m is equal to 0. Is that okay?
Yes, sir.
Quantum numbers alla ಓದ್ಕೊಂಬರ್ಬೇಕಪ್ಪ. See, I told you last class, the full concepts ಮರ್ತ್ಬಿಡ್ತೀರ. ಅದೇ ಪ್ರಾಬ್ಲಮ್. ಈಗ ಇದೆಲ್ಲ ಬೇಡ. ಐ ಥಿಂಕ್ ಆಲ್ ದೀಸ್ ಥಿಂಗ್ಸ್ ವಿ ಹ್ಯಾವ್ ಡನ್ ಸಮ್ ಟೈಮ್ ಬ್ಯಾಕ್. ನಿಮ್ಗೆ ಬೇಕಾದರೆ ನಾನು ಆ ವಿಡಿಯೋ ಹಾಕಿದ್ದೀನಿ, ಹೌದಾ? ಸೊ ಐ ಹ್ಯಾವ್ ಪುಟ್ ಇನ್ ದಿ ವಿಡಿಯೋ ಇನ್ ದಿ ಗ್ರೂಪ್ ಅಬೌಟ್ ಕ್ವಾಂಟಮ್ ನಂಬರ್ಸ್ ಎಲ್ಲ. ಅದನ್ನು ಒಂದ್ಸತಿ ನೋಡಿ, ವಾಚ್ ಮಾಡಿ, ಆಯ್ತಾ? ನಿಮ್ಗೆ ಇಷ್ಟು ಸಾಕು. ಇದು ಸೊಲ್ಯೂಷನ್. 1s L is equal to 0. You have to count s electrons and 2 electrons in p. So 2 plus 2 plus 2 electrons of p and 1 electron of s. Totally 6 plus 1, 2, 4, 6 plus 1, 7, 9, 7. So totally option 2 is the correct. Is that okay? Shall I proceed now?
Yes, sir.
Next question. The stability of ferric ion is due to half-filled d orbital, half-filled f orbital, completely filled d orbitals, and completely filled f orbitals. Which is correct?
Half-filled d
First
orbitals.
option, sir.
Ferric ion will have 3d5. Okay, so that's fine. So you can see iron atom, atomic number is 26. It will have 4s2 3d6 outermost. Fe3 plus means remove 3 more electrons. So 3 electrons, which are those you are going to remove? You are going to remove 2 electrons here, and 3d6, 1 electron you are going to remove. Okay, so it becomes 3d5, 4s0. 3d5 means half filled. Exactly. So half filled and completely filled orbitals are more stable. This half filled d orbital is the correct answer. Half filled d orbital. Shall I proceed?
Yes, sir.
Third, if n is equal to 6, the correct sequence for filling of electrons will be. This I told you, half-bow principle. 1s2, 2s2,
1, sir.
2p6.
Option 2, sir.
Option 2. Because from 6 onwards, F also starts filling. When F starts filling, the shell value should be 2 less than shell value of S. And for D, shell value should be 1 less than shell value of S. Yeah, and P should be same as that. So option 2 is correct. So from 6S, because 6th shell means 6S it fills. So therefore, 6S, 2 less 4F, 5D, 6P is the correct one. So option 2 itself is correct. We'll take a fourth one. 4D, 5P, 5F, and 6P orbitals are arranged in the order of decreasing energy. The correct option is decreasing order. You can do n plus L rule, or if you remember the sequence according to Aufbau principle, you can directly answer. Whichever has highest n plus L value will be the one which has highest energy.
First option, sir.
Okay.
Yes, sir. First option.
What is n plus L value here? 5 plus 3, 8. And 6 plus 1, 7. 6. 6. Between 6 and 6, lower n value will be lowest energy. Am I right? So in that way, so that itself is the correct answer. Option. Shall I proceed now?
Yes, sir.
7th, the order of filling of electrons in the orbitals of an atom will be.
Option 2, sir.
Option 2, sir.
4s3D, 4p,
2, sir.
5s4. Okay. So again, you can go for Aufbau principle or n plus L rule. So correct answer. Okay. If anybody are writing, please let me know. Okay. Shall I proceed now?
Yes, sir.
Yes, sir.
8th, total spin resulting from a D7 configuration is.
3 by 2.
Because how many unpaired electrons are there?
3.
Exactly. So when it is D7, 7 electrons, how do they fill into D subshell? 5 electrons go singly occupied. After 5, 6th electron gets paired, 7th electron gets paired. So if you see how many unpaired electrons, n value, n is unpaired electron, 3. So each electron will have plus of spin. So because arrow mark upward, plus of into 3 is 3 by 2. So option 1 is correct. Okay. What is the spin value of D5 configuration? Anybody?
5 by 2.
5 by 2. What is the spin value of D3 configuration?
3 by 2.
3 by 2.
D9,
1 by 2.
D8,
1.
D2,
1.
1.
D6,
2.
2.
D4,
2.
Fe2 plus,
3 by 2, sir.
2.
2,
5 by
because
2.
Fe2 plus is
5
3d6.
by 2.
Oh, okay, 2, sir.
3d6, 3d6 means 4 unpaired electron. Mn2 plus,
5 by 2.
good, like that. Okay, fine. We shall proceed. Ninth, if a shell is having G subshell, which is correct statement about principal quantum number n of the shell?
Option 2.
Option 3.
Option 3. It should be n is equal to 5 or greater than 5 or equal to 5. That's all. In 6, it will not be there. Huh?
Sir, it may, sir.
So option 2 is correct. So for G subshell, L value is 4. For L value to be 4, N value should be greater than 5 or more than 5. Okay. So it may be equal to 5 or more than 5. Because for every N value, L can have value starting from 0 and ending with N minus 1. So L value finally will be 1 less than N value always. So for G subshell, L is 4. So N should be 1 greater, 1 more. So N should be either 5 or more than 5. It simply means like this. This is nucleus, first shell, second shell, third, fourth, fifth. You know, you have different subshells in each orbital. Let me take a different color here. Okay. In first shell, there is S subshell, 1s. This is 2s, 2p. Like that, 3s, 3p, 3d. 3d adds to third shell. In fourth shell, which are the subshells present? 4s, 4p, 4d, and 4f. Am I right? So 4f is the one which is newly added there. Similarly, in fifth shell, 5s, 5p, 5d, 5f, and 5g will be present. And 5g, if once added from fifth shell, even in sixth shell it will be present, seventh shell it will be present. Okay. So in that way, option 2 is the correct. Okay.
Yes, sir.
Yes, sir.
Sum of electronic spins of all electrons with the configuration 3d5. Sorry, how much is it? 3d5. Just remove that. 3d7 again. It's the repeated question. 3d7 is again 3 by 2.
3 by 2, sir.
11th, the respective values of orbital angular momentum of an electron in 1s, 2s, 3d, and 3p orbitals are. Now, angular momentum is given by the formula.
Under root L into L plus 1, L into L plus 1 into H by 2 pi.
Very good. Who said this?
Ujjwal, sir.
Ujjwal. Fantastic, man. Okay. Come on, calculate now. For s orbital, L is equal to 0. For d orbital, L is equal to 2, p1. Then you can give the value. Wherever 0, for s orbital 0, 0 is there, that should be the answer, right? So there are two options which are ruled out now. Option 2 and 3 are ruled out, right? It should be either option 1 or 2. Come on.
Option 4, sir.
Correct. So for L 1s, L is equal to 0. For For 2s, L is equal to 0. So angular momentum in both the cases becomes 0. For 3p, L is equal to 1. You can substitute here root 3 into h by 2 pi it becomes. Okay. Root 3 into h by 2 pi. For d, L is equal to 2. It becomes root 6 into h by 2 pi. So if you see the answer, which is the correct one?
Option 1.
For 3p, L into, it is option 1, correct. It's not root 3, it is root 2, correct. Okay, I'll give you the solution. You can. This is root 2, right? Root 2 into h by 2. If it is complete, I'll proceed.
Yes, sir.
Maximum number of electrons in a subshell with L is equal to 3 and N is equal to 4 is
14, sir.
okay. What is L is equal to 3 actually?
F orbital.
F subshell can accommodate 14 electron because there are 7 orbitals in it. You can also say number of orbitals in a given subshell is 2L plus 1. Each orbital can accommodate 2 electrons. So number of electrons in a given subshell is 2 into 2 plus 2 into 2L plus 1 becomes 4L plus 2. No problem. L is equal to 3 means it is F subshell. Directly you can say F14 maximum electron. Okay. 13. Which of the following quantum numbers is correct for an electron in 4f orbit?
First option, sir.
N is equal to 4, L is equal to 3, M1 is off. Okay. What is not correct in option 2?
Sir, it can be plus
M cannot be
minus 3 and 0, sir.
This is not correct. When L is equal to 3, maximum M value can be plus 3, that's all. Not plus 4. Because M varies between minus L to plus L. Minus 3 to plus 3. So fine. In third option, what is not correct?
It should be from 0 to n minus 1.
So when N is equal to 4, L maximum value should be 3, not 4. What is not correct in option 4?
Sir, they have asked for 4f orbital, sir, but they have given for p, 4p orbital.
Fantastic. It is D actually.
Okay, sir, D.
So they have actually asked for 4f. So this is wrong. Fantastic. So option 1 is correct. Okay. I'll proceed now. number of orbitals used by chromium for filling its electrons. How many orbitals are used by chromium for filling it? What is the atomic number of chromium? I told you atomic number up to 30. All the elements, their atomic numbers, electronic.
24, sir.
Pardon me?
24.
24. 24. If each orbital can accommodate 12 electrons, sorry, 2 electron, how many orbitals are required there?
Well,
24 electrons are there in chromium. If each orbital requires 2 electrons, how many orbitals are filled up by 24 electrons?
well,
Then is that 12 is the answer? Can I freeze 12 as the answer?
Yes, sir.
No, because in the valence shell there are unpaired electrons. So therefore 12 cannot be the answer. You can see here chromium atomic number 24. You can see up to 3p all the orbitals are exactly completely filled. Whereas after 3p there are 6 electrons present in not 3 orbitals. 6 electrons occupy 6 orbitals. So totally up to 18, 9 orbitals are filled. 9 plus 6 would be 15.
Yes, sir.
Oh.
Sir, continue. Sir, can you continue next class, sir?
Thing is, now what is the time now? I didn't see. 11:33. You have next 12, no? 12 o'clock.
Yes, sir.
Okay. So fine. We shall stop at this stage. Meet for the next class. You can't. We can't take one more class in between, no? Any time weekdays. In the weekdays, can we take the class?
Sir, which day, sir?
No, whichever day is convenient for you. I also should check my timetable actually. I'll also be very much occupied. Like any one day, generally evenings you will be free, all of you? No. You will
Sir,
have
evenings we have tuition, sir.
Okay, no problem. We'll go a little slow. Rather, it's not slow. It has become damn slow. Very slow it has become.
Sir, at night one class we can have, sir. Weekdays.
Oh, for you it may be very hard. Okay. By January 1st or 2nd week, we shall see what can be done because your college classes will get over somehow. And if once you are free in the college hours, then we can plan for. Not now. It becomes too much heavy on you. Okay. Simply listening from morning to evening is really difficult. No problem. We have enough time. We shall go with the same pace. No problem. Fine. We'll take up remaining questions and few questions on node concept, nodes. Okay. And then we'll move on to the next chapter. Okay. We'll stop at this stage. Thank you. Nikita, I came to know. I'll just relook into it. Okay. Probably I would have entangled. Nikita is there? Nikita? Okay, she left. Okay. We'll meet.
Thank you, sir.
Bye-bye.
Thank you, sir.
thank you, sir.
Yeah.
Thank you, sir.
Thank you. Okay, I'll send the recording in the WhatsApp. No problem.
Yes, sir. Thank you, sir.
Yeah, yes.